Okay, so if you're involved in training large language models, you know the drill. Speed and memory are everything. Well, you need to hear about this recent update from the team at Unsloth because it's a genuine game changer. It promises to completely shake up how we approach fine-tuning. Let's get right into it.
Right off the bat, let's just talk about the headline number. With their latest update, Unsloth is making it possible to train your models up to 5 times faster. Nope, not a typo. 5 times faster. Think about that. Something that used to take you all day could now be done before you even break for lunch. But that's not even the whole story.
Because the other piece of the puzzle is memory. Unsloth's new methods can slash your VRAM usage by a massive 90%. What this means is you can train bigger, more powerful models on much smaller, way cheaper GPUs. This just blows the doors open for so many more people to get into serious AI development. So you get faster training and lower hardware costs. You've got to be asking,
how on earth is that possible? Well, it's not magic, even though it kind of feels like it. It's actually a super clever solution to a problem that's been quietly slowing down GPU-based model training for years, a problem of just immense computational waste.
So, the secret villain in our story of slow model training is this thing called padding. It sounds totally harmless, right? But in reality, it's a massive resource hog that just grinds everything to a halt. Let's break down exactly what it is.
You see, GPUs are incredible at doing tons of things in parallel, but they have one little weakness. They need all their data to be perfectly uniform, like soldiers in a line. So to process a batch of text, every single example has to be the exact same length. If one is short, the system has to pad it out with these useless blank tokens just to make it fit the mold.
And this visual just says it all, doesn't it? On the left, that's your actual data, all different lengths, just like in the real world. But on the right is what the GPU demands. The best analogy is shipping. Imagine you have a tiny little item, but the only box you have is huge. What do? You fill that box with tons of packing peanuts just to ship that one small thing. Well, the GPU is spending a huge chunk of its time and memory processing those packing peanuts.
And this leads to something really weird and counterintuitive. You'd think, hey, I'll just give the GPU a bigger batch of data to work on. That'll be faster, right? Wrong. Because of padding, a bigger batch often just means more waste. The single longest sentence in the batch forces all the other sentences to be just as long, so you can literally slow down your training by trying to do more at once. It's crazy.
So how does Unsloth tackle this padding monster? Well, they've come up with this brilliant two-part strategy that attacks the problem from both a low-level hardware angle and a really smart data logistics angle.
first, they got their hands dirty and rewrote some of the really fundamental code that runs on the GPU using something called fused kernels. And second, they invented this technique they call uncontaminated packing. And trust me, this is where the real magic happens. Let's look at the kernels first.
Before we get to the packing, we have to understand the foundation they built. Unsloth went deep, I mean way down into the low-level code that handles some of the key calculations for these models.
So, a key calculation in a lot of modern LLMs is called rope. In the past, this needed two separate operations, or kernels, on the GPU. Think of it like making two separate trips to the store. What Unsloth did was fuse them into a single, super efficient trip. Just this one change makes that specific calculation 2.3 times faster and cuts down on memory traffic. It's a huge win that lays the groundwork for what's next.
Okay, so with that foundation in place, let's move on to the star of the show, packing. This is the big idea that directly attacks all that padding waste we were just talking about.
I mean, just look at this. The difference is night and day. On the left, that's the old way. 4 separate examples, each stuck in its own shipping box, filled with all that wasted padding space. But on the right, that's the Unsloth approach. It cleverly takes all 4 items and fits them snugly into a single, continuous line. Like a master Tetris player, there is almost zero wasted space.
And this is the whole point. The GPU is now spending pretty much 100% of its time processing actual, meaningful data, instead of those useless padding tokens. It's the difference between a fully loaded cargo train and one that's half empty. The efficiency just goes through the roof.
And the math behind these huge speedups is actually pretty straightforward. Let's say your data set is about half long sentences and half short ones. By packing them together and eliminating all that padding, you get a solid 2x speedup. But, and this is key, what if your data set has lots and lots of short sentences? Maybe 80% short. Well, that's where you see those mind-blowing 5x gains, because you're getting rid of a massive amount of waste.
Okay, so the theory sounds amazing, right? But does it actually work in the real world? Well, Unsloth ran the benchmarks to prove it, and yeah, the results are pretty impressive.
So this chart shows us one of the most important metrics there is, tokens per second. It's basically a direct measure of how fast the model is chewing through data and learning. And you can see it plain as day. With Unsloth's packing turned on, the throughput is consistently 1.7 to 3 times higher. That means you finish your training runs in half, or maybe even a third of the time.
And here's a really stark look at why it's so much faster. This chart shows that in a normal training run, with even a small batch size of 8, nearly half, 50% of the tokens being crunched by the GPU are just useless padding. That is a staggering amount of wasted electricity and time that Unsloth's packing just completely wipes out.
Now, for any developer, this is the million-dollar question. Okay, it's fast, but does it mess with my model's accuracy? And the answer, according to Unsloth's own tests, is a definitive, absolute no. The training loss curves, which show how well the model's learning, are identical. You get the exact same quality model at the end of the day, just in a fraction of the time.
So after seeing all of this, you're probably thinking, okay, I need this. How do I get these benefits for my own projects? Well, this might just be the best part of the whole thing.
That's right. Just by updating to the latest version of Unsloth, you automatically get a big chunk of these speed and memory improvements. A more basic version of this padding-free approach is now the default. You don't have to change a single line of your code to get a nice 1.1 to 2x speed up.
But what if you want the whole shebang? You want those maximum 2x to 5x gains we've been talking about. It's literally one line of code. In your training configuration file, you just add packing equals true. That's it. One little change unlocks all of this power. It's incredible.
And really, this brings us to the final, most important question. This isn't just a small incremental update, it's a major leap in efficiency. When your training runs are 5 times faster and need way less hardware, it opens up a whole new world of possibilities. For more experiments, for new applications, for people who are maybe priced out before. So the real question Unsloth leaves us with is, what will you build with it?